Chapter 4, Hypothesis Testing. Here's my summary of Chapter 4. Section 4.1 introduces you to the idea of hypothesis testing, a little bit of the outline of how it works. Philosophically, the null hypothesis is sort of the status quo, the tried and true, or possibly the hypothesis of no effect. The alternate hypothesis represents the new idea, often the thing you're trying to prove, or that the two things are connected. So almost philosophically, we kind of sit on that null hypothesis. We assume the null hypothesis is true until we find compelling evidence to suggest otherwise. And what compelling means is different depending on the context of the experiment. If it's something like a medical trial, we're going to require very strong evidence before we move from, say, an existing established drug to a new drug. In other situations, we might be less discriminating. The language of statistics is really centered around the null hypothesis, so we'll often say, reject the null hypothesis, which is equivalent to saying we support the alternate, but the phrase commonly used is reject the null. Or failure to reject the null hypothesis really means we're just supporting the null hypothesis. I know it's a little bit weird, but that's really, the language supports this philosophy of kind of sticking with the null until we find compelling evidence to move away from it. Section 4.2 moves us into maybe one of the most abstract things we'll deal with in this class, and that's the p-value. We'll have lots of practice with p-value as we consider different examples. Please take your time with this section. Establishing good foundation for what a p-value is will help improve understanding later on. A few quick notes about the p-value. We always consider the distribution suggested by the null hypothesis. So that again would be the distribution as suggested by the status quo. You'll see examples in the book to kind of help flesh this out. A p-value is a quantification of our data. We gather our data and we kind of turn it into a p-value either through the bootstrapping or some other method. And if we end up with a large p-value, that will tend to support the null. A small p-value will tend to support the alternate. And how do you know what's large and small? That will depend on this sort of cutoff, which you'll see in examples. Do note in section 4.2 in a lot of the diagrams and a lot of the pictures, the way they compute the p-value is they look at the observation and they move to the extremes to compute that p-value. And that's certainly no accident. Section 4.3, determining statistical significance. One thing to note is they'll talk about error in this. When you're planning an experiment, you always want to anticipate the possibility of error. In statistics, we can often actually compute the probability of making error under certain conditions. And this is a very valuable thing to do when planning ahead. Again, large p-values support the null, small p-values support the alternate, and to determine what's large and small, we set a level of significance. So look for that specific concept in this section. And the level of significance is our cutoff between supporting the null or supporting the alternate. Again, large p-values support the null, small p-values support the alternate. For example, consider the smiles and leniency example on page 223 of the text. I like this example. One, I think it's interesting, and two, I think the methodology is also very insightful. I also like this because it's something we would assume is true anyway. People who smile more or appear friendly probably get more lenient treatment, and we certainly suspect this, but somebody actually went to the work and the trouble to prove it, which is often very useful. So several subjects we're shown pictures of suspects, people suspected of cheating at a college. Some of the pictures of these suspects were smiling and some were not, and each of the subjects was asked to determine what sort of punishment was appropriate, and from the punishments a leniency score was computed for each of these subjects. And so you have an average mu sub s for all the smiling pictures, and a mu sub n for all the neutral pictures, people not smiling. And so the hypothesis, the null hypothesis, is that the two are the same, that there's no smiling or not smiling has no effect. Right? Again, the null hypothesis is often the hypothesis of no effect. And the alternate is the thing we're trying to prove, that people who are smiling get treated more leniently than people who are not. And so that's kind of how you set up hypotheses. Section 4.4 again moves you more toward how you compute p-values, and this is done using randomization distributions. I have some videos kind of demonstrating how to do this, which will also help you do the homework. In particular, the example I like in this section is this example concerning aggressive-looking football uniforms and the penalty yards that teams with these aggressive uniforms get, and understanding whether or not those two things are actually correlated. So aggressive-looking uniforms, more penalty yards, and trying to see if that's actually a thing or if it's just something people say or one might suspect. Section 4.5, confidence intervals and hypothesis testing. So last chapter we learned a lot about confidence intervals, and that is another kind of way we quantify certainty, and hypothesis tests use p-values, which also quantify certainty. So in 4.5 we investigate those connections. Again, 4.5, chapter 4 is kind of the meat of this course in a lot of ways, which is why it's good we're looking at this early to give us some time to really develop these ideas. And that's that. Again, as always, please let me know if you have any questions. Take your time with this chapter, and I'll talk to you later.